Good morning, everybody, and welcome to our lesson 7. This is the second last lesson in our booklet. So let's just talk about this. This chapter 7 talks about the trig identities, and so far we've talked about trig identities of the reciprocal, the quotient, and the Pythagorean theorem identities. So today we're going to talk about the sum and difference identities. I just want to point out something that some of these identities are all on your booklet. Oops. But the identities are also in here. Okay, so I just want to point out the identities that we're going to talk about are here. Okay, so the difference means subtraction, and then the sum, which is the addition of angles. So I don't want to take a lot of the time, so just let's dive right into this one here. So in terms of sum and difference, the sum and difference identities are identities that work with the sum and difference of two angles in standard position. So we're talking about two angles that are added together and they are creating new identities. So what are they? Let's take a look. So the very first one is sine of alpha plus beta. So when we take alpha plus beta, okay, so this is your first angle, and then if you have the second angle, you add them together and you take the sine of that. It's the same thing as taking the sine of the first angle, cos of the second angle, plus cos of the first angle times the sine of the second angle. And then we look at this one again. You have angle A and angle B, or alpha and beta. So if we add them together and we take the cos of those two angles together, it's the same thing as cos of the first angle times the cos of the second angle minus sine of the first angle times the sine of the second angle. So all of these things are written for us. We actually don't have time to prove all these stuff, but we will just take it as it is because, yeah, we won't have time to prove them. So we'll just use them in terms of evaluating. So we're going to use that to evaluate. We're also going to use these trig identities to solve equations. And yeah, so we'll go right in. One application of these new identities is to find the exact values of trigonometric ratios for non-special angles. So before we talked about special angles. So what are the special angles that we talked about? Okay, so the special angles are 0 in terms of degrees. So 0, that's going to be, what else? 30, these are degrees, 45 degrees, 60 degrees, and 90 degrees, and and any multiples of some of these angles. Okay, so and their multiples. Okay, so now when we come across something like this, determine the exact value, okay, of sine of 75. Now we could go like this. We could let me turn on the light here. There you go. We could go sine of 75. Sine of 75. We're going to get this number, but this is actually not the exact number. This is a decimal approximation of the number. They're asking for the exact. So how can we figure out the exact in this particular case? So let's use the trig identity that we know of. Well, how can we get a 75? How can we get 75 from any of these angles that we know of? Well, to get a 75, we can go 30 plus 45. That makes 75. So we ask ourselves, how can we use the special angles, okay, to get this angle here, 75 degrees. Okay, so we know that we can go 30 and 45. So we're gonna use 30 degrees plus 45 degrees, because that's gonna give us a 75. And then these are the sum of the angle. So we're making a sum of the angle. So when we say sine of 75, it's the same thing as sine of 30 plus 45. And these are all degrees. So this is your alpha angle, and then this is your beta angle. So what can we do? How do we expand this? What's the identity for that one? So let's go. Sine of 30 plus 45. So sine of alpha plus beta could be expanded like this. So let's do that. So this is the same thing as sine of alpha, which is 30 degrees, times cos of beta, so cos of 45 plus cos of alpha is 30, sine of beta is sine of 45. So I'm just gonna kind of put it on the side in here. We're gonna use the identity, the sum and difference identity, sine alpha plus beta is equals to sine alpha cos beta plus cos alpha sine beta. So we're using this one. And then we're putting in this particular case, alpha is the 30 degrees, and then our beta is equals to 45 degrees. We're putting them in there. Okay. So now, okay, well, what's this gonna equal to? What do we know of? Okay, so let's kind of visualize our unit angle again, unit triangle. So we're gonna take a look at 30 degrees and 45 degrees. So 30 degrees would be right there. So 30 degrees, the coordinate for that is root 3 over 2, comma 1/2. And then 45 degrees, so this is the 45 degrees, and it's going to be root 2 over 2, comma root 2 over 2. So we're going to use these values for that. Okay, so let's go here. What's sine of 30? So this is our 30 degrees right here. Sine of 30 is 1/2. So we're going to put 1/2 here. Times cos of 45. Okay, so this is the 45 degree angle right there. So cos of 45 is the x coordinate. So it's going to be root 2 over 2. Okay, so I'm just following this part here, plus cos of 30. Okay, so 30 degrees is here. Cos is root 3 over 2. And then finally, sine of 45. So this is the 45 degree angle. Sine of 45 is the y coordinate of that point on a unit circle, so it's going to be root 2 over 2. Now we can simplify that. Okay, so that's going to be 1/2 times root 2 over 2. We're going to multiply numerator times numerator, denominator times denominator. So that's going to give us root 2 over 4 plus, okay, same thing in here, root 3 over 2 times root 2 over 2. We're going to multiply those two together. So root 3 times root of 2, that's the same thing as root of 6 divided by 4. So we can go further. If we wanted to, we can combine these two fractions. They have the same denominator, so we can say root 2 plus root 6 over 4. And that's the answer. Okay, so we see, well, what's that equal to? Remember earlier we said sine of 75? Sine of 75, this is the approximate value is 0.965925 and so on. That's approximate. This is the exact. Well, let's take a look. Are we going to get the same number? Okay, we're going to get this number equaling to 0.96. Let's see. So the numerator is root 2 plus root of 6. So I'm going to go root of 2 plus square root of 6. Okay, I'm putting it in a bracket because I want the calculator to take all of these in the numerator and then divide it by 4. Okay, so as you can see, it's the same value. Okay, so when they ask for exact, okay, we have to use the sum and difference of angles in that case. Okay, so that's one example. Let's take a look at example number 2. Example number 2. This one's a little bit different because the angle here is pi by 12. Okay, there's many different strategies that I've seen that people use. Okay, I've seen some people change this into what do you call it? A degree, and then use that because it's easier, right? So that's a possibility, certainly. Or another possibility is just to work it out. So I'm going to show you how to do that again. Okay. Now, because this is in pi radians, not in degree, so we have to kind of think about what are the special angles. So let's just write it down over here. Special angles in radian. Okay, so in terms of radian, well, it's going to be 0 radian. Okay, that's the very first one. The next one would be pi by 6 radians, pi by 4, pi by 3, pi halves, and then from here, we just end there and there, multiples. Okay, so multiples of these angles there. Okay, so how do we do this part in here? I'll show you. This is pi by 12, pi by 12. So what we can do is we can say, okay, how can we do pi by 12? Well, let's see. Tan of something okay. So what we could do is we can think of, okay, well, if it's on pi by 12, um, this is 1 pi by 12. So what we could do is we can say, okay, we could go 4 pi, 4 pi by 12 minus 3 pi by 12. Okay, so writing it the same denominator first, and then let's see if we could clean it up a bit, because sometimes this is the challenging part, is to figure out, are we going to add, are we going to subtract, right? So how can I get 1? Okay, well, from here, 4 pi by 12, we can say, oh, well, 4 pi by 12, we can rewrite that as tangent of, that we could be dividing, that's pi by 3 minus, and then we can simplify this, and then this is going to be pi by 4, pi by 4. Okay, so there we go. So we got the difference of two angles in here. So how do we do this part? Okay, so just to kind of remind ourselves that this is, we cannot use a distributive property of multiplication, okay? Because 10, we can't just multiply it in, okay? So that doesn't work here because this is not a term. This is a function. So how can we go tan of these two angles? So let's take a look. Well, we can say tan, the difference of the angles is tan of the first angle minus tan of the second angle all over 1 plus tan of the first angle times tan of the second angle. So in this case, alpha is equals to pi by 3 and beta is equals to pi by 4. And because we're using the difference of angles using the tan function, so we can say tan of alpha minus beta is equals to tan alpha minus tan beta divided by 1 plus tan alpha tan beta. So we're just going to substitute these values in there. Okay, so let's do that. Okay, so this is what we're following in here because we have a difference of angles. So tan alpha, so tan of pi by 3 minus tan of pi of beta, which is pi by 4, divided by 1 plus tan of alpha, so tan of pi by 3 times tan of pi by 4. Okay, so because all of these are in tangent, let's see if we can, let's remind ourselves what the tangent is for those angles. Okay, so our first angle is pi by 3. So where's pi by 3? From here to here is pi. Pi by 3 is here. Okay, you know that already because we've done chapter 6. So this is pi by 3. And that one is 1/2 comma root 3 over 2. Okay, and then pi by 4 is again right here, and it's root 2 over 2, root 2 over 2. This is sine, this is cos, this is the sine. Okay, the first is the cos, and then the second is the sine. We want tangent. So tangent, what is tangent? Tangent is sine divided by cos. So that means the tangent of pi by 3, tangent of pi by 3 is root 3 over 2 divided by 1/2. So if we do that, root 3 over 2 divided by 1/2, the 2's cancel. We're left with the root of 3. And then tangent of pi by 4 is root 2 over 2 divided by root 2 over 2, which is 1, So how do we do that? Let's see. I'm running out of room, so I'm just going to go this way. So tan of pi by 3, that's going to be root 3 minus tan of pi by 4 is 1 divided by 1 plus tan of pi is root of 3. Tan pi by 4 is 1. So it looks like it's going to be like that. We can't subtract these two. They're not like radicals. So we can say root of 3 minus 1 over 1 plus root of 3. And that would be the exact value. Okay. So that's that one. Now let's see here. Okay. This is just to show or to kind of verify our work or verify our answer. It helps like just to see that it is like what we did is correct. So we can go here. Okay. I know they asked for the exact, but I'm just gonna type that in. I can go tan of pi by 12. Okay. I'm gonna get oh no, that's not true. I'm gonna change it to radian mode. Okay, there you go. Tan of pi by 12. Okay, so tan of pi by 12 is 0.2679 dot dot dot. Okay, goes on. So this is the approximate. That's approximate. And when we use the trig identity in here, this is what we got, the exact value. So I'm just gonna show us that it works. It's the same answer. So I'm gonna go root of 3 minus 1 divided by 1 plus root of 3. So let's do that. Okay, root of 3 minus 1 divided by 1 plus root of 3, and we get the same thing, 0.26. So that one was good. It was really good. Okay, so I'll give you a moment to just maybe copy that down, last lines. And then we're going to move on to example number 3. Example number 3. So it says here, example 3, given an angle alpha in standard position with its terminal arm in quadrant 2, cos of alpha is negative 5 over 13. And angle beta is in standard position with its terminal arm in quadrant 1. Okay, we're gonna draw this out so we can make sense of this. And what else? Sine of beta is 3/5. Determine the exact value. Okay, they want the exact value of cos of alpha minus beta. So how do we do this part in here? Let's see. Let's start with this one here. Angle alpha is in quadrant 2. Okay, Okay, so angle alpha is in quadrant 2, like that. Okay. And it says cos of alpha is negative 5 over 13. So that means, okay, cos of alpha is equals to negative 5 over 13. What does that mean? Cos is negative 5 over 13, which makes sense because it's on the left side, right? Cos is negative on the quadrant 2. What does this really mean to us? So if this is the angle, this is adjacent over hypotenuse. Adjacent over hypotenuse. So if this is negative 5, hypotenuse is 13. So what can we do here? We have to figure this out. Okay. And we know how to do this because we already did this in chapter 6, part 1. Okay, so what's the y value of that? Okay, well, we'll see. It's x squared plus y squared is equals to r squared. Okay, so r is 13. So 13 squared. X is negative 5. So negative 5 squared plus y squared. Let's work it out. So y squared is equals to 169 minus 25. So y squared is 144. And then we're supposed to take the square root. Okay, oops, I don't need another square root there. Square root of this. Now, because we're taking the square root, we should be really looking at the sign. It should be plus or minus, but let's take a look. Because this is in quadrant 2, y should be a positive. So it's going to be positive 12. Since the angle is in quadrant 2, y is positive 12. Okay, so what does that mean? If cos of alpha is negative 5 over 13, then we can say sine of alpha is, okay, and alpha, we're going to be using the reference angle in here to figure out the sine. Sine is opposite over hypotenuse. So that's going to give us 12 over 13. Okay, so I'm going to pause right there for a second and let you kind of think about what just happened there. Okay, so that is for alpha because alpha is in quadrant 2. Let's take a look at beta. Okay, it kind of gives us a clue. And angle beta is in standard position with its terminal arm in quadrant 1. So we're going to go, let's draw it out. It's good to draw it out because you want to have something visual. Okay, so in quadrant 1, that's where angle, we don't know exactly where it is, but we know it's in quadrant 1. So this is going to be our beta in standard position. Okay, so what did they say? They said sine of beta is 3/5. That's the information that they gave us. Sine of beta is equals to 3 over 5. So that means, okay, I'm going to bring this down here. Make that a little bit smaller. So beta is 3/5. What does that mean? Beta, sine of beta is opposite over hypotenuse. Opposite over hypotenuse. So where's the opposite side? Opposite is 3. Hypotenuse is 5. So we're really looking for this piece right there. So let's do that. How can we do that piece? The x value. Okay, well, we're going to use the Pythagorean theorem again. X squared plus y squared equals to r squared. X squared, we don't know, so this is our x. We don't know, so we're just going to go x squared plus y squared. So y is 3. That's going to be 3 squared equals to r squared. R is the radius. That's going to be 5. So 5 squared. And then, of course, we can solve out the x. So x squared is equals to 5 squared minus 3 squared. So that's going to be 25 minus 9. So x squared is equals to 16. Now we're going to take the square root. We're going to take the square root. Let's take a look. Square root of 16 should be plus or minus 4, but we have to figure out, which one is it? Is it the plus 4 or a minus 4? Because this is in a quadrant 1, the x is positive. So that means this is going to be just positive 4. So this is going to be 4. So if sine of beta is 3 over 5, then the cos of beta is equals to adjacent over hypotenuse, which is 4 over 5. Okay, so I'm just going to go here, adjacent over hypotenuse. Okay, great. I might as well put that in here. This is going to be opposite over the hypotenuse. So for this example 3, there are a few things that we have to lay down first. We have to take a look at information, looking for extra information for that. Okay. Now that we have all of these information in front of us, we can say determine the exact value of cos alpha minus beta. So when we go here, cos of alpha minus beta, well, that's a difference of angle. So what's the identity for that one? I'm just going to use my formula sheet in here. Cos of alpha minus beta. So cos of alpha minus beta, we can rewrite it like this. Cos of alpha cos beta plus sine alpha times sine beta. Okay, let's put in our values. We don't know what alpha and betas are, so we can't really put in any values there. But we know what the cos of alpha is. So cos of alpha, that would be this one over here. Cos of alpha, bring it down a bit, is negative 5 over 13. So we're going to put down here negative 5 over 13. Okay, so now the next part is cos of beta. So we also know that one. Cos of beta is 4/5. We're going to put that there. plus okay, now let's take a look at this one, sine alpha. So look at this part here. That's the one that we figured out at the beginning. Sine of alpha is 12/13. So 12/13. And then sine beta is 3/5. 3/5. Okay, so how do we simplify that? We can just multiply numerator and denominator. So -5 times -5 times 4 is -20 over, oh, how much is this one in here? 50/65. Okay, so this simplifies to -20 over 65 plus 12 times 3 is 36 over 65. Okay, so that's going to be 16 over 65. Okay, and we can just leave it like that. Okay, so this one here has a lot of work that needs to be done. Okay, so we did example 1, example 2. We just finished example 3. So let's keep going. This one here, it says, write each expression in the simplest form. Okay, so in the simplest form. So how can we write that down in simplest form, then evaluate where it's possible? So, I mean, right now, we could technically evaluate this, right? Because pi by 2 is a special angle, right? We know what pi by 2 is, tan of pi by 2. And we know that minus tan pi by 3, we could figure that out. And yeah, so technically we could evaluate this the way it is because these are special angles. But it says here, write it in simplest form and then evaluate. So let's try that. What can we see? This is a whole bunch of tangent stuff. So tan of an angle minus tan of the second angle divided by 1 plus tan of pi by 2 times tan pi by 3. So that kind of looks like a tangent, but which tangent is that? Okay, I got to make sure that here. So this tan pi by 2 is the alpha, and pi by 3 is the beta. Okay, and then this is alpha again, and then this is beta. So I just want to make sure that it's in the same form. So tan of alpha, which is pi by 2, minus tan of beta, which is pi by 3, divided by 1 plus tan of alpha, again pi by 2, plus tan of beta, which is pi by 3. And they said that, hey, I can take all of these and simplify it by writing tan of alpha minus beta. So we can write that as tan of alpha, which is pi by 2 minus pi by 3. Okay, well, how can we do tan of pi by 2 minus tan pi by 3. We can simplify this inside. So tan, we can multiply this by 6. That's the same thing as, no, we can multiply by 3/3. So that's going to be 3 pi by 3, 3 pi by 6 minus 2 pi by 6. Okay. And when we have tan of 3 pi by 6 minus 2 pi by 6, that's the same thing as tan of pi by 6. Okay, well, what's tangent of pi by 6? Pi by 6 is this one right there. That's a special angle, so we could technically figure that out. So this one here, that's going to be root 3 over 2 comma 1/2. So this is a cos and this is a sine. So that means tan of pi by 6 is sine divided by cos. So 1/2 divided by root 3 over 2. The 2's cancel. We're gonna get 1 over root of 3, which is 1 over root of 3. Okay. Is that good? So what I can see, okay, let's see here. Tan of pi by 6, oops, tan of pi by 6 is going to get 0.577. And if I go here, this is going to be 1 divided by root of 3 is 0.577. So there we go. Okay. I'm going to try to speed things up in here. I know I'm pausing quite a bit, but so that it's not way too long, and you have time to do your work. So let's take a look at this one. Sine of 8x times cos of 3x minus cos of 8x times 3x. So sine 8x, that would be your alpha. 3x would be the beta. Again, alpha. And then this is the beta. Okay. So how can we simplify this? We can simplify that by saying, let's see, sine of alpha cos beta, sine of alpha cos beta minus cos alpha sine beta. So we can simplify that as sine of alpha minus beta. Sine of alpha minus beta. So alpha is 8x minus 3x. And we can simplify the inside. So sine of 5x. In this particular case, we can't really evaluate this. It's not possible to evaluate it because we don't know what the x is. So that's our simplified version. Okay. Now we get into proving the identity. So y is cos of pi by 2 minus x is the same thing as sine of x. Oh, I actually wish I could do this on Desmo, and then show it to you. But if you want, you can go to Desmos and type this in individually and you'll see that they're the same. Okay, so how do we do that? Cos of pi by 2 minus x. Let's see. Well, what we can do is we can expand this. This is the left side, and then this is the right side. Now, because we're proving the identity, we don't want to switch things around, okay? We can't be moving any term on the left side or the right side. We're going to work it out in here and simplify, make sure that the left side um, is the same thing as the right side, basically. So we're going to start with a complicated one and make it to a simpler one. How do we do that? So cos of pi by 2 minus x. Well, this is a difference of angles. So how can we figure out cos, the difference of that? So we say we're going to use this identity, right? So cos of pi by 2 minus x, we can expand it using the identity. Cos of the alpha, this is your alpha, the first one, pi by 2, times the cos of beta, which is x, minus, plus sine alpha is pi by 2, and then sine beta, so sine of x. Okay, so this is our alpha, and this is our beta. So using the trig identity, we can do that. Now from here, well, cos of pi by 2, where's pi by 2? Pi by 2 is right here. That's 0, 1. So cos of pi by 2 is 0. 0 times cos of x. Okay, we can't figure this out because we don't know what that angle is, x. Sine of pi by 2, what's the sine of pi by 2? Sine of pi by 2 is 1. So 1 times sine of x, and you're probably seeing it right now. 0 times cos of x is 0. 1 times sine of x is sine of x. So 0 plus sine of x is sine of x. So the left side is equal to the right side. Okay, so we did have some identities here. Okay, now let's take a look at this one. This is our left side, and then this is our right side. We're going to start with this one, the difference of the angles. This is our alpha, and then this is our beta. So sine of, we're going to use this identity. Sine of alpha minus beta, because we have a difference of the angle. Okay, good. So let's write that down. Sine of pi minus x, that's the same thing as sine of pi times cos of x minus, I'm gonna run out of room in here. Start this way. Sine of pi times cos of x minus cos of pi times sine of x. Okay, let's see. Well, where's pi? Pi is right here. Okay, pi is right there. So the point there is -1, 0. Okay, so sine of pi, that's going to be 0 times cos of x minus cos of pi. Cos of pi is -1 minus -1 times sine of x And then this is going to be gone. And you got negative times negative is going to be positive. Positive sine of x, okay, is equals to the sine of x, which the left side is equals to the right side. To see this visually, to visualize this, you can use Desmos, okay. I mean, we've used Desmos in class before when we were doing transformations and all that, but you can use Desmos in your browser, and then you can just type in y is equals to cos brackets pi by 2 minus x, and then the other one is y is equals to sine of x. Okay, so for this one, the very first one, and then you'll find that it produces the same graph. Okay, produces the same graph. Now the other thing too is that we have to make sure that it's in the radian mode, because if it's in the degree mode, it's not going to work. So make sure it's in the radian mode. Okay, and then you do the same thing for that one. You'll see that they will produce the exact same graph. Okay, let's go to the last one, example 4. Example 4, okay. Now, when we did something like this in lesson 1, we can just use the same, we're going to use the trig identity to simplify, and then we're actually going to use that to solve eventually. So what does that look like? This is our alpha, this is our beta, beta. Okay, so this one here looks very complicated. Okay, well, what does that simplifies to? Sine of alpha cos beta minus minus cos beta sine alpha. What would that be? That would be sine cos minus cosine. So sine cos minus cos sine, that would be this identity right here. Sine of alpha minus beta. So all of these could be simplified as sine 5x minus 3x equals to 1. Okay, and we can simplify that further. So we can say sine of 2x rather. Okay, so where do we go from here? What can we do? We're trying to solve for x, okay? We're not proving it, we're solving it. There's a difference in here. So what we're going to do is we're going to manipulate the equation so that we can have the x isolated. So what can we do? We can take the sine inverse of both sides. So take the sine inverse. Now take this sine inverse of both sides of the equation. Okay, so that's going to give us sine, and sine inverse cancels each other out. So 2x is equals to sine inverse of 1. So what is that one? So sine inverse of 1, that's going to give us pi halves. Okay, so sine inverse of 1 is pi halves. And And then we're solving for x, so divided by 2. So x is equals to pi by 4. So x is pi by 4. Now let's just take a quick look in here. Because this is a double angle, the b is 2, therefore since b is equals to 2, when we're looking at the b value in here in terms of our transformation, the period has now changed. The period of the graph changed to p equals to 2 pi over b, which is 2 pi over 2, which is really just pi. So the period now is pi. Okay, so the answer is going to be pi by 4, pi by 4. So that means this x here is really pi by 4s, pi by 4. So the solution is x equals to pi by 4. And if we wanted the general solution, okay, the general solution is x equals to pi by 4 plus pi times k, where k is an element of the integer. I know that they're not asking for the general solution, but if we were to later on, if we get asked for the general solution, we know how to do it. Okay, so that's that one. Okay, let's take a look at the last one. Okay, we're going to be a little bit over, but it should be okay. But this is the last example. Cos of 4x times cos of x plus sine of 4x times sine of x is equals to 1. Okay, where is this? So this is our alpha, this is beta, plus sine of alpha, sine of beta. So where is cos plus sine? Okay, let's take a look at this. Cos plus sine. That's how I look at it. Cos of alpha, cos beta plus sine alpha, sine beta. So we're really focusing on, we can simplify all of that into cos of alpha minus cos of alpha minus beta. So all of these can be simplified to cos of alpha, which is 4x, minus beta, which is x, equals to 1. Okay, so again, simplify this part over here. This is going to be cos of 3x equals to 1. Oh, my kids are home. Hello. Hello. Okay.
Hello.
Okay, be quiet. I'm not done. So cos of 3x equals to 1. How can we figure this out? How can we solve for x here? What we're going to do is we're going to take the cos inverse of each side. So cos inverse of each side. So if we take the cos inverse and cos, they cancel each other out. We're left with 3x. And what's the cos inverse of 1? So they're asking for what angle is it that the cos is 1? Cos of what angle will give us 1? That would be a 0. So Okay, so if you want to do that, like, um, and then divide by 3, divide by 3, so x equals to 0. So x is 0. And now, since the b value here, okay, since the b value is 3, the period is changed to p equals to 2 pi over 3. Okay, so that's the new period, 2 pi over 3. Therefore, the solution is x equals to 0, x equals to 0, and the general solution, okay, if later on you're asked for what is the general solution would be x equals to 0 plus 2 pi over 3 times k, where k is an element of the integer. Okay, so here you go. Okay, so we're pretty much done. Thank you so much for participating in our class. All of the notes will be posted on the blog. So they're going to be all there. What else I was going to say? I would ask you to, try some of these questions, give them a try, and then if you come across something that you are not sure of, or if you're having some difficulty, please let me know, and then I will help you out with some of the questions. If you have any questions, just send me an email, and then I'll try to get back to you as soon as I can. Okay, but I think for now, thank you very much again for watching and participating. And I guess I will either talk to you later or I will talk to you tomorrow. Okay, have a good day, everybody. Okay, bye for now.